Hello, welcome back to Solve with Danny, and today we're going to practice quotient law as well as making sure we keep our exponents positive, because you always want to write your final answer with positive exponents. And if you need a review on law of exponents, check out previous video in this playlist where I go over all the laws of exponents. It's only 10 minutes, super quick. All right, so I did get this worksheet from Kuta Software, and I'm going to skip around it just a little bit. Some examples will have algebra, some will have regular numbers, some will have both. So let's dive in. Okay, so we'll just start with the first one, and I will write out these steps in the early one just to make sure you recall the laws. So we are going to, when we have the same base, write ourselves a little note up here. Same base, we will subtract the exponents, okay? And I'll show you why that works, and then from now on, we'll just subtract, all right? So 5 to the 4th really means I have 5 times 5 times 5 times 5 all over. If I have 5 technically to the first, I do like to write that little 1 exponent. I just have 1 there. When you have the same thing divided top and bottom, it's really like you're canceling out to a 1. So we are left with 5 to the 3rd power, which 4 minus 1 is 3. Life is good. You can simplify that out to 125 if you really want, but we just want to mainly focus on practicing these problems, right? Okay, and I encourage you at any point during this as well, if you want to pause the video, try the problem on your own, hit play when you're ready to see like, how did you do? Definitely go for it. All right, so here, I'm going to write this one out as well, because if you do 2 minus 3, we get 2 to the negative 1. We don't like negative exponents. So let's check this out. Let me use a different color. All right, so that's really like having 2 times 2 on the top and 2 times 2 times 2 on the bottom. When we simplify out, we're left with technically a 1 over 2 to the first, or just 1 over 2. So that's why, and again, review my exponents video, these two are equivalent, but we don't want to write it with negative exponents. Remember, the rule is you put this over 1, it comes on down. So 1 over 2 to the first is the answer we would want to see. If you write it as a negative exponent, you're going to lose a point. All right, so keep those exponents positive, but that's why it works. That's why that property works, okay? All righty. Let's get to a beefier one. Let's check out number 5. So when we have real life numbers, if we can simplify those real life numbers, that's great. In this case, we cannot, so we will keep them on the top and on the bottom. Now we do have some same base exponents here, r cubed and r technically to the first power. Well, what's 3 minus 1? It is 2. So we get r squared positive on the top. Okay, and again, if you want to expand that out to see them canceling out, you totally can. But if you start getting higher exponents, it might be obnoxious. Okay, all right, so let's check out number 6. So again, real life numbers, if we can simplify them, cool. If not, we just leave them. Oops. Leave them be. That is a 4. Get a little ahead of myself there. Now here we have k squared on the top, k cubed on the bottom. We want to write it with positive exponents. So 2 minus 3 is negative 1. So you're going to write k on the bottom because that's where more of the k's are. That's where it's going to stay positive, because you're going to have k times k over k times k times k. Pew, pew. That k is left on the bottom. You would like to keep it there. So 7 over 4k is the correct final answer for that problem. All right. Ooh, we can simplify this one. Yay. Okay. So let's do a little simplifying with the regular numbers. 10 over 6, they are both divisible by 2. So that means 10 divided by 2 is 5. 6 divided by 2 is 3. So we have 5 over 3. We have p to the 4th on top, p to the 1st on the bottom. 4 minus 1 is 3. So we get 5p cubed over 3 is our final answer. All right, for this next one, why don't you try it solo, see how you do, okay? So 3 and 10 do not simplify, so we're going to write them as they are. And then we have a b to the 1st on top, b cubed on the bottom. When you subtract them, you get squared, and we keep it on the bottom because we want to keep it positive, okay? We want to keep it positive. I guess we can do number 9. All right, so let's simplify. These are both divisible by 2. So we get 4 and 5. Now, m cubed and m cubed, it's exactly the same. 3 minus 3 is 0. 0 raised, anything to the 0 power is 1. So technically, that cancels out, and we're just left with 4/5. Life is good. Life is good. All right. Number 10. Again, try it solo. See how you do. 7 and 2 do not simplify. And then we have n cubed, n to the 5th. 3 minus 5 is 2. We're going to keep it where the higher exponent is because that means there's more of them. So we're going to keep it down at the bottom. It keeps it positive. All right. Okay. Let's go to something juicier. Let's go to number 14. All right. So these are both divisible by 2. So we get 7 and 3. Now I'm going to highlight my exponents just so we can kind of keep them separate there. Oops. Equal sign. So we have 7/3. So x to the 4th on top means there's 4 of them up there. X to the 5th, there's 5 of them down there. I'm going to have an x left, and we keep it on the bottom to keep it positive. Next, we have the y's, 7 of them on top, 4 of them on the bottom. 7 minus 4 is 3. There's more on top than there is the bottom. So 7y cubed over 3x is your final answer for that one. Very good. All right. Try number 15 on your own, okay? So 11 and 17 do not simplify. And then for our exponents here, we have u's. We do not have any v's on the top, so v to the 9th will stay on the bottom. And let's see here. We have 4 u's. We have u to the 4th on top, which means there's 4 of them. U to the 7th on the bottom means there's 7 of them. There's more on the bottom. 4 minus 7 is 3. U cubed will stay on the bottom. So 11 over 17 v to the 9th u cubed. Or if you wrote it as u cubed and then v to the 9th, that's okay too. Both are equivalent. All right. Let's try out number 16. These are both divisible by 2. So we have 2/7. And then again, I really love highlighting when I have a lot of stuff going on. X to the 8th, there is no other x's on top. So x to the 8th is going to stay where she is. That y on the bottom technically has a 1 on the exponent, so we're going to keep it there. So y to the 4th over y to the 1st. 4 minus 1 is 3. There's more y's on top. So y cubed is on top. So 2y cubed over 7x to the 8th. All right, we'll do one last one. And if you really want a part 2 to this video with more practices, request it in the comments below. 16 and 9 do not have any common factors. It cannot simplify. So that will stay as it is. Let's do some highlighting because they were a little sassy here. They changed the order on us. Regents exams love to do that. So that's why this highlighting technique is just so helpful. So let's start with the x's. We have x to the 4th on top, x to the 8th on the bottom. There's more on the bottom than there are at the top. And 4 minus 8 is 4. So we're going to keep x to the 4th on the bottom, so we keep it positive. And then on top, we have y to the 1st. On the bottom, y squared. There's more variables of y on the bottom. So y, or you can make it as y to the 1st, will be on the bottom. So 16 over 9x to the 4th, y to the 1st. So I hope this helps. If you'd like another part 2 of this video, comment below. I hope you hate math a little bit less. And don't forget to like and subscribe. Bye, everybody. Thanks for coming to Solved with Danny.